Welcome to the Explainer. Today, we're going to be digital detectives. We're going on a mission to uncover the secret life of our computer programs. The life that happens in this hidden world we almost never get to see.
I mean, really think about it. You write your code, you tell the computer what to do, but when it comes to memory, grabbing it, releasing it, this whole other hidden system just takes over. Well, we're about to build a tool to spy on that very system and find out what is really going on. You see, every program has this invisible force working inside of it, a system that manages one of the most critical resources it has. We call it the default memory manager, and for most of us, it's a total black box.
So you can think of this manager as like a silent partner for your code. Every single time you create an object or a list or anything, it steps in, finds a little piece of memory, and just hands it over. And when you're done, it cleans up after you. It's absolutely essential, but how it actually works, that's a mystery. And that's our whole mission today. You can't fix or optimize something you can't see. So our goal is simple. We're going to crack open this black box and get a front row seat to every single memory operation our program makes. Okay, so how are we going to build this spy? We're going to create our own custom memory manager. But here's the twist. It's not actually going to manage any memory. Nope, it's just going to watch and report back on everything it sees. The idea is actually pretty simple, but it's really powerful. Our spy is going to act like a middleman. Every time the program asks for memory, the request has to go through our logger first. It'll just scribble down what happened, who asked, how much, and when, and then pass the request along to be handled like normal. So if you want to get into the nitty-gritty, what we're really doing is hijacking the standard memory functions. We write our own versions of getMem, freemem, and reallocatemem. Then we just tell the system, hey, from now on, whenever anyone talks about memory, send them to my guys first. And this is absolutely key. Our spy is an observer, not a replacement. It logs the request, and then it immediately hands it off to the original, battle-tested memory manager to do the actual work. This way, we get all the intel we want without, breaking the entire system. It's a simple, elegant plan. Or so it seems. Right. Here's where our nice, simple plan smacks right into a fascinating, kind of mind-bending problem, a logical trap that could bring our whole program crashing down. Think about it. Our logger's job is to write things down. To do that, it needs to create strings. A little log entry that says allocated 100 bytes. But here's the catch. Creating a string requires allocating memory. And hey, this isn't just some weird theoretical problem I'm making up. The official documentation literally warns us about it directly. We are now inside the very system we're trying to use, and the rules in here are completely different. This breaks down the trap perfectly. Our logger needs memory, so it calls the memory manager. But wait, it is the memory manager, so it calls itself, which of course needs memory, so it calls itself again and again and again in an infinite loop until, boom, Stack Overflow, our spy has spied on itself right into oblivion. So, if we can't use our program's own tools to do our job, how in the world do we escape this paradox? We have to go outside the system. We've got to find a deeper, more fundamental set of tools. And here is the really clever workaround. Instead of asking our program for help, we're going to go over its head and talk directly to the operating system. We'll use the fundamental Windows API calls that exist way down below our application's memory manager. We're basically tunneling our way out of our own system. This slide shows the trade-off perfectly. We have to give up all our convenient, high-level tools. No more easy string formatting. No more simple number-to-string converters. Instead, we have to do everything the hard way, manually, using these raw, powerful, but much more difficult commands like create file and write file to talk directly to the OS. So our clever solution works. We escaped the paradox. Our spy is successfully logging memory calls. Awesome. But the investigation isn't over. In fact, solving that one problem has just revealed a couple of new and pretty critical ones. As we start analyzing the logs from our spy, two major design flaws become painfully obvious. First, it's not safe for modern multi-threaded apps, and second, it is incredibly slow. First up, thread safety. Just imagine two different parts of your program trying to write to the log file at the exact same instant. Without some kind of lock to make them take turns, they just slide right over each other, corrupting the log file and probably crashing the entire application. Our spy just can't handle a crowd. And the second flaw.
performance. That low-level write file call is powerful, sure, but it's also really expensive, computationally speaking. A normal program makes thousands, maybe millions, of tiny memory allocations. Writing to the disk for every single one creates a massive bottleneck. Our whole program slows to a crawl, hobbled by the very tool that was supposed to be helping us.
A more professional, real-world spy wouldn't report every little thing as it happens. No, it would be much more patient. It would collect all of the memory logs in a big, pre-allocated buffer and then write that entire chunk of data to the disk in one single, super efficient operation. So after this whole journey, building a spy, hitting a paradox, finding a workaround, and then discovering all new flaws, what's the real lesson here? What did we actually learn from this little adventure? Well, the first lesson is just this incredible appreciation for all the invisible machinery. That simple command to allocate memory that we take for granted, it's sitting on top of a deep, complex, and fascinating system. This whole exercise just reveals how much work is being done for us, silently and reliably every single second. And the second, and maybe more crucial point, is that in engineering, there's no such thing as a perfect solution. Our simple logger was elegant, but it ran into a paradox. Our low-level API solution worked, but it was slow and wasn't thread-safe. A buffered solution would be faster, but way more complex to build. It is always, always a balancing act. And that brings us to the final thought. This whole explainer was about the memory manager, sure, but the principle applies to everything. So ask yourself, what are the hidden systems, the black boxes, that you rely on every single day? And what might you discover if you decided to build a spy to look inside?